Chapter 3. Connecting to servers and transferring files. In the last chapter, we learned what servers are and why bioinformatics needs them. Now it's time to actually connect to one. The standard way to access a remote Linux server is through SSH, which stands for Secure Shell. SSH creates an encrypted connection between your local computer and the remote server, allowing you to run commands on the server as if you were sitting right in front of it. To establish an SSH connection, you need 4 pieces of information. First, the IP address or hostname of the server. This is the network address that identifies which machine you want to connect to. Second, your username, which is the account that has been set up for you on the server. Third, your password, which authenticates your identity. And fourth, the port number. SSH uses port 22 by default, but many institutions change this to a custom port for security reasons. Think of it like making a phone call. The IP address is the phone number, the port is the extension, and your username and password prove you're authorized to use the system. Let's look at how to actually use SSH from the command line. The basic syntax is simple. You type SSH followed by your username, the @ symbol, and the hostname or IP address. For example, SSH John at 192.168.1.100. If the server uses a custom port instead of the default port 22, you add the -p flag followed by the port number. For example, SSH-P 10088 John at 192.168.1.100. There's one important thing to know about typing passwords in Linux. When you enter your password at the SSH prompt, no characters are displayed on screen, not even asterisks or dots. The cursor simply doesn't move. This is completely normal and is a security feature. If you make a mistake, just press backspace several times and retype your password. Many beginners think their keyboard isn't working when they first encounter this. Don't worry, your keystrokes are being recorded. While the command line works perfectly for SSH connections, there are also dedicated SSH client applications that provide additional features like session management, tabbed terminals, and integrated file transfer. Let me walk you through the most popular options. For cross-platform tools that work on Windows, macOS, and Linux, there are 2 excellent choices. Termius is a modern SSH client with a clean interface and built-in SFTP support for file transfers. Tabby is an open-source terminal that's highly customizable. For Windows specifically, there are several more options. Xshell combined with XFTP is a powerful combination that's free for home and school use. PuTTY is a lightweight, free classic that's been around for decades, and MobaXterm is feature-rich with an embedded X server for graphical applications. For macOS users, you already have the built-in terminal app which handles SSH natively. No extra software is needed. However, if you want more features, Secure CRT and Royal TSX are popular commercial options. Sometimes SSH connections fail, and it can be frustrating when you can't figure out why. Let's go through the most common problems and their solutions. The first issue is wrong credentials. Double-check your username spelling. Make sure your password has the correct case, since Linux passwords are case-sensitive, and verify you're using the right port number. The second common problem is network restrictions. Some institutions and universities block external access to their servers. In this case, you may need to connect through a VPN first before you can SSH into the server. Third, the SSH port might be blocked. Some networks, especially corporate or hotel networks, block port 22. If your server uses a custom port, make sure you're specifying it correctly with the -p flag. Fourth, the server might be overloaded. If the server's CPU is at full capacity, SSH requests will queue up and the connection will appear to hang. The solution is simply to wait and try again later. And fifth, general network congestion can cause timeouts. Check your own internet connection first before assuming the server is the problem. Now let's talk about transferring files between your local computer and the remote server. The first tool we'll cover is SCP, which stands for Secure Copy. SCP uses the same SSH protocol, so it's already available on any system with SSH. To upload a file from your local machine to the server, you type SCP followed by the local file name, then your username at hostname, and the destination path. For example, scp data.fastq.gz john at server :data/. To upload an entire directory, add the -r flag for recursive. For example, scp-r myproject/john at server :tilde/. Downloading works the same way but in reverse. You put the remote path first and the local destination second. So scp john at server :/path/2/file.txt. Copies a file from the server to your current local directory, and scp-r downloads a directory. If the server uses a custom port, use capital P instead of lowercase p. For example, scp-P 10088 file.txt john at server :tilde/. The second command line file transfer tool is SFTP, which stands for Secure File Transfer Protocol. Unlike SCP, which copies files in a single command, SFTP gives you an interactive session where you can browse directories, navigate around, and transfer multiple files. To start an SFTP session, type SFTP followed by your username at hostname. Once connected, you'll see an SFTP prompt. From here, you can upload files with the put command, or upload entire directories with put-r. The mput command lets you upload multiple files using wildcards, like mput*.fastq.gz to upload all fastq files at once. For downloading, use get for a single file, get-r for a directory, and medget with wildcards for multiple files. SFTP also has navigation commands. Use ls to list remote files and lls for local files. Change remote directories with cd and local directories with lcd. Print your working directory with pwd for remote and lpwd for local. When you're done, type bye to close the session. If you prefer a graphical interface for file transfers, FileZilla is an excellent free option. It works on Windows, macOS, and Linux, and provides a drag-and-drop interface for moving files between your local machine and the server. You simply enter the hostname, username, password, and port, then click Quick Connect. The interface shows your local files on the left and remote files on the right, making transfers intuitive. Finally, let me mention Visual Studio Code, or VS Code, with its remote SSH extension. This is a game-changer for bioinformatics work. Instead of just connecting to run commands, VS Code lets you edit files directly on the server with full syntax highlighting, run code remotely, and even view various file formats like images and PDFs. It essentially turns the remote server into your development environment. Many bioinformaticians now use VS Code as their primary tool for writing scripts, editing configuration files, and reviewing analysis results on remote servers. That's everything you need to know to connect to servers and transfer files. You now know how to use SSH for remote access, SCP and SFTP for command line file transfers, and graphical tools like FileZilla and VS Code for more visual workflows. In the next chapter, we'll start learning Linux commands, beginning with navigating the file system. If you found this helpful, please like and subscribe.